Hello, everyone. Thank you for the intro. My name is Brenden. I work at Mesosphere on the customer happiness team, self-appointed to that team, which I also created on my first day there. Tonight, so first of all, just out of curiosity, was anyone here at the Mesos meetup last night, also in New York? At least one person. So I'm sorry if some of this kind of looks like deja vu. It kind of is, but there's also some new stuff in. So I'm going to make this as interesting as possible. If you guys have questions or anything, try to hang on to your thoughts, and there'll be time at the end for me to answer some of those. And if we don't have time to get to all of them, then I'll be around, and you can just come and grab me. So, one sec. All right, so the agenda. First of all, I want to talk about DCOS, which is our product at Mesosphere. DCOS stands for Data Center Operating System, and we think this is going to be a big deal. So I'm going to do a quick demo of what it looks like to start up a cluster with DCOS Cloud, and then I'm going to do some demos with Docker Swarm, as well as with Marathon, using some different Docker features. I'm also going to show what cluster resizing looks like on AWS with Auto Scaling Groups, which is pretty cool, and then do a bit of a use case discussion, and then should have some time at the end for questions. So first of all, DCOS. If you're not familiar with DCOS, it's our stack that's made up of Mesos, or the Apache Mesos project, which is the kernel for your data center. It's analogous to the Linux kernel. On top of that, you have Marathon, which is like your init for your data center. And then your apps, your Docker apps, let's say, can run on top of Marathon, or you can run Swarm on Marathon, and then your Swarm apps on Mesos as well. So I recorded a little video of what the DCOS Cloud Formation provisioning process looks like on AWS. It's going to go by really quick here. You click a link, and it pops open the console, and you can select some parameters. You have to specify, for example, an SSH key. If you're familiar with AWS, some of this might look familiar. And then you click some more buttons. Got to check a box, and click another button, and then it launches your cluster. So this process takes about 30 minutes to go from having nothing to having a Mesosphere cluster up and running with DCOS. Now, I'm gonna talk a bit about the features for Marathon and Swarm, and the differences between the two systems, and why you might want to use one over the other. So Marathon is Marathon's an init for your data center. It's like the the equivalent of your PID 0 in a Unix system. It has a simple, easy-to-use REST API. It's been battle tested at scale. A number of companies are using Marathon in production today. It has a bunch of different features that make app deployment and orchestration really easy, like constraints, app groups. It has built-in support for health checks, and deployment strategy features. And I'm going to demo some of that. But before I do that, I'm going to demo Docker Swarm. So Swarm is like Docker's native integration for running your Docker containers in a cluster. The Docker Swarm's main feature, I would say, is that it integrates really well with the existing Docker tooling, like the command line stuff. So you don't, if you already know how to use Docker, it's pretty easy to get started with Docker Swarm as well. It has a bunch of features, and I should mention that at this point, Docker Swarm is just in beta. And the Mesos integration for Docker Swarm is very early at these stages. So I'm going to demo it, and I hope it works, but it's not representative of the final product. It also supports a bunch of service discovery backends like etcd, console, zookeeper, and it has features similar to Marathon-like constraints and affinities as well, which is a new concept that it has. So to start off, I'm going to launch the Docker Swarm Manager with Marathon, and I have to type to do this. So let me see if I can improvise with the microphone here. I got an idea. I am an engineer, so not like a real engineer, but software sort of. It's not really engineering. Okay, so I'm going to pop over. I had a terminal. There it is. Is that visible from far away? Okay. Is there any chance we can turn the front lights off here? Is that possible? Maybe? Well, we'll see. Okay, so I've prepared some stuff in here, and I'm going to show you what it is. So first of all, I've scripted out my commands ahead of time, just so I can keep on track here. Cool. It's like we're in a theater. So the first thing I'm going to do is I'm going to launch Docker Swarm. So I'm going to kind of walk through what I'm doing here. So that cluster that I booted up already is currently running, and I have my Marathon running here. Now, Marathon has very nice REST API, and typically you would interact with Marathon through that API. So I'm going to show you what the Swarm Marathon definition looks like and explain it a bit. So this is just a blob of JSON, and it contains an ID, a name. In this case, I'm calling it Swarm Manager, and then the command we're running, which is, we're calling Swarm and enabling debug flag and passing some parameters. We're going to put the cluster mode, set the cluster mode to Mesos, and then we're telling it how to find the Mesos master. And I'm using Mesos DNS, which is a DNS server that the DCOS includes for service discovery. Another thing may be interesting is that I'm running Docker Swarm itself, of course, as a Mesos container, as a Docker container, and I'm using this Mesosphere Swarm image that we built with that Mesos tag. So, and there's some environment variables as well that are getting passed into Docker Swarm to tell it what port to bind to and what address. Okay, so to run this, I'm just going to run this command here. So this is going to send an HTTP post to Marathon, which is at that address. Enter. So Marathon responds with its version of the config that I just sent, which has all the unpopulated default values filled in. And now if I jump over here and I look, I can see that my Swarm Manager is deploying. Now if I jump over to the Mesos UI, which is a separate thing, I can see that it's currently staging on this host. I'm going to go into the sandbox. It's still staging. It's thinking about it. All right, we're going to accelerate this process. Whoops. So what's happening right now is Mesos is, well, it's done now. The staging means that it's basically doing a Docker pull from Docker Hub. So Swarm Manager is now up. It's running. It's printing some debug info to the logs. You can look at std out. There's nothing meaningful in there. Perfect. Everything looks good. So now I have Docker Swarm up. What do I do with it? Well, I can interact with it just like any other Docker command. So what I need to do is, that's too small. I'm going to SSH into one of the hosts in the cluster, and I'm going to run some Docker commands, but I'm going to do them with Docker Swarm. So what's happening here is so Docker Swarm communicates over Docker's built-in TCP API, or its remote API. And all I'm doing is passing the host name, which in this case is going to be swarmmanager.marathon.mesos, because it's the ID for the app is Swarm Manager, and it's running on Marathon on Mesos. And those DNS entries are provided by Mesos DNS. And then we've got the port set ahead of time, and I'm just going to run a PS. Uh-oh. Uh-oh. Okay. We're going to restart Swarm, see if it works this time. This is very early beta software, like I mentioned. So it is up, just listening. Oh dear. Oh dear. Let me just try killing it again. And unfortunately, this demo is not going as well as expected. So well, rather than trying to debug this up here, I'm going to talk through what the other steps are and what they would look like. I can assure you, however, I tested this right before this talk, and it did work then. But yeah, okay. So I'm just going to destroy Docker Swarm kind of out of spite right now. There, it's gone. Get out of my face. Okay, so had Docker Swarm been working, I could have run a PS and it would list all the containers that are running. I could have started Nginx, let's say, which is what I could have started Nginx, although I had this demo, so I could just do docker-h and then specify the host name. Although you could set this as say an environment variable. So you don't have to type it every time, and then you can just do docker run and tell it how many CPUs you want, how much memory, specify the image, and then a command. This one does while true due date, which prints out the date to std out, and then it sleeps, and it just keeps doing that forever in a loop. It would have made for a very exciting demo, I assure you. And it might work then, yeah. Y2K or something, I don't know. Yes, so then you can kill the container after it's running, and all this, of course, happens on top of Mesos using the Docker Swarm Mesos integration. Okay, so that was fun. Now I'm going to show you some of the features that Marathon has for working with Docker as well. So Marathon's a pretty mature service at this point. It works pretty well with Docker. It does not work with the Docker command line directly, but rather you describe your applications to Marathon and specify how the container should be run in Marathon's own language. And I'll show you a little bit about that. Okay, back in the pocket. So first thing I'm going to do, I've got this simple Python thing here. And what this is, so this is a little HTTP server, and it just runs this command. It just says python-m http.server. That's it. Boom. It's going to be wild, blow your mind. All right. You guys ready? Boom. Okay. So now it's running. It's up. There's 2 instances of it. There's one. Marathon in the UI provides these handy little links to the task, and I'm going to click on one, and it's not going to work. There's nothing there. It's not available. Reload. Nope. No go. So there's a reason for that. It's because this Python thing is binding to some random port. I don't know what. It's kind of crazy. If we look at this, we'll see, oh, well, it's just running this random Python command, python-m http server, and we have no idea what port it's on. So let's change this here. Let's specify a port. Let's tell it that we want it to use the first port that Marathon is giving us. Okay. Now I'm gonna post that again to the Marathon UI. I'm going to destroy this one first. You don't have to actually destroy it like that, but I did it anyway because I didn't like it. And now it's going to come up again very soon. There it is. I can click on it, and now I have these handy links with ports, and I can click on them. Oh, and look at that. I got something. This time I got a directory listing. So what this Python HTTP server does is just list all the files in the current directory. It's very exciting. So next thing I'm going to show you is a little fancier. This time what I'm going to do is I want to run Nginx, which is a cool sounding web server, and this one is running in a Docker container. And there's something very interesting going on here, which you may notice, which is these port mappings. So Docker by default uses this bridged networking thing, which is kind of difficult sometimes, but Marathon provides a nice way to map the ports directly to whatever you want, and it provides this tool called Marathon, or HA Proxy Marathon Bridge, I think it's called, to hook your services that are running up to something like an HA proxy for service discovery and load balancing, failover, and that sort of thing. So let me launch this. So now I have my Nginx. I'm going to destroy my Python thing. That's coming up. Look at that. It's already started. Boom. Welcome to Nginx. So I just launched my Nginx server on Marathon. I actually have 2 of them running independently. Prove to you. There's the other one. Welcome to Nginx. So what about something more interesting? What about, say, a MySQL or SQL, depending on what you believe in? So this is just the official MySQL container. I'm going to go ahead and run that. There isn't anything special going on here except, my root. That's not my real root password. Don't get any ideas. And I'm also applying a constraint here. So this is an important feature that Marathon has. And what this constraint says is that this task can only run on, it can only run one instance per hostname. The hostname has to be unique for every instance of that task it launches. Okay, let's run it. All right, we should see it pop up in a second. There it is, MySQL. Look at that, we're ready to go. Now we can do something really crazy. I'm going to go ahead and run this. Oh, hold on a sec. I need to look at my commands because I can't remember this. Type it out. Let's see. So what I'm doing right here is I'm running the Docker
MySQL container from the command line here. I don't think that's the right port, but that looks like a good port. Looks like it's on 8082. Passing my top secret root password, and so if this worked, I should be able to hit enter, and this is going to select some stuff from one of the internal MySQL schema tables that mean, oh, look at that. There we go. So I just launched my MySQL. It's up. I can query it from my other Docker container with MySQL, and that's that. So I'm going to blow that away, and I'm going to show you one more cool thing before I run out of time here. I've been kind of talking into my pocket here for a while. So I would like to show a feature in Marathon called, a feature that's in both Marathon and Mesos. This actually exists in the core Mesos, but it's a health checks feature. So I have some. I'm also showing app groups, but I won't go into that in great detail. So I have this group of applications here, and once again, they are just little Python web servers that are going to show me what the contents of the working directory that they have are. So I launched that. Now I have my groups. So you'll notice that it's launching the common service first, then it's launching service A, and when all of that comes up, it's going to go ahead and launch service B. However, this is kind of pointless because I'm not actually doing any health checks on any of these services, so just because they're running doesn't mean they're actually working. And what I'm going to do is add some health checks very quickly to show you what those look like. So, where did I put my health check? Oh dear. Oh dear. Just a moment. Well, let's see if I can just do it from memory. All right, so I believe we're going to say health checks like this. We're going to pass it an array, and we're going to say mode. This is going to be an HTTP health check, and I believe it takes a path, and the path is just going to be /. All right. So I just added a health check to this common service, and I'm going to, I have to do a put. Marathon API kindly informed me that I already created that, so I have to update it in place. So it's going to do a new deployment, and it looks like it accepted my health check. So I'm just going to look in the browser here at the Marathon API and see what my app definition looks like and whether or not it accepted my health checks. Oh, look at that. Okay, good. It did. So you'll notice that it filled in the default values, which I did not specify, which is great because I didn't remember what they were. Oh, and there we go. So you'll notice something very interesting is happening, which is there are actually 4 instances of the common service coming up, and that's because now that we have health checks, we can do a proper deployment. And so the way that the deployments work is that Marathon will start the new instances, wait until they become healthy, wait until the health checks are good, which it looks like they are not right now. So that's troublesome. Whoops. Oh, there we go. Sorry. There, it's green, or it's yellow. Well, presumably I made a mistake in here, but oh no, it's green. There we go. So as these services come up, Mesos is checking the health of each of them, and if for some reason they go unhealthy, Marathon will take care of redeploying the unhealthy services. I can apply the same health checks to the other apps in my definition here. And then I can show you very quickly JSON, commas. Put that, whoops. I messed it up. That needs a comma. That needs a comma, yes. This does not. There we go. Okay, so I just relaunched it, and now I have health checks for all of my services. And you'll notice that Marathon is deploying these two because I changed those, but I did not change this. Now it's deploying service A first. It started 2 of those. Those are going to come up. And once the health checks go green, it's going to launch service B. Now, I didn't really explain why it's doing that in that order, but if you look at the definition, you'll see that I've specified these dependencies. So I've said that this service B here depends on department A, product A, service A, and service A here depends on this common service. So the common service needs to come up first, and then the other 2 come up, and so on. So I'm going to stop with the demos there, and whoops. So port mappings, constraints, app groups, and deployment strategies. These are 4 great features in Marathon that I don't need that in my pocket anymore. I can take it out. So these are great features that allow you to build your microservices or not microservices architectures on top of Marathon and interact with it using the REST API, using tools like that HTTPie thing, HTTPIE, if you haven't heard of it, which is pretty nice. So I'll stop there and open it up for some questions. Yes, in the back, sir. So the question is, for everyone, he's asking, let me repeat it, tell me if I'm wrong, but he's asking, for people who are using something like Marathon, should they also be interacting with Mesos? And should there be a trapdoor in there? Is that right?
Basically, yeah.
Yeah, so I think for the most part, the answer, the place we want to be is that people never interact with Mesos. They interact with services that run on top of Mesos. In the same way that, when you're using the Linux kernel, you don't actually, you don't type system calls into Bash or something like that. You use Bash, and Bash is interacting with the underlying file system APIs and so on for you. We think that, the things like Marathon and Kronos, I didn't talk at all about Kronos, but Kronos is another scheduler, provide the features and tools that you need to cover most use cases for running data center applications. Yes, sir.
So app group, it is a Mesos concept, Mesos component, or is part of Marathon?
Good question. So the question is, are the app groups a Mesos concept, or is that a component of Marathon? And the answer is that is a feature in Marathon. Other services have similar concepts with different names, but the general idea is, typically you have applications that depend on other applications, and you should really surface that at your orchestration and like pass layer, basically. Any other questions?
Yes, sir.
Hi. So we've seen how spinning up services in this cluster works, but how, generally speaking, do requests from the outside world get load balanced to one of these instances, one of these containers, rather?
Right. So I mentioned briefly about load balancing. So Marathon provides a tool called Marathon the Marathon HA Proxy Bridge. It might be HA Proxy Marathon Bridge, but whatever.
basically, what you can do is hook HA proxy up to Marathon by, like Marathon can publish the, like the topology of your apps, and then HA proxy's configuration can get updated automatically, and HA proxy does its thing. If you've used HA proxy before, it works pretty well for that. And there's not a lot that needs to be invented there. That said, we think that the whole service discovery thing and like basically getting your apps found by other things is a lot harder right now than it should be. Mesos DNS is one of the tools that we built, which should make that a lot easier. But at the same time, DNS doesn't solve all problems. It has its own problems, like the TTL issue and caching, that sort of thing. Any other questions? Yes, in the back.
Just to relate to that question about services and port bindings and that kind of stuff. As you start to have more and more services, relying on the fact that when you say define dependencies, you get the right string, because it's just a string. I don't know how refactor safe you find that in practice, but ultimately you want across multiple teams some shared catalog of which services exist. If you're using like a port binding, which port numbers they have. Do you have some kind of thoughts around how to validate something like a Marathon setup to make sure that you're using the right stuff?
Okay, so the question is, how do you make sure that people aren't stepping on each other's toes, basically, in an organization with ports and services, because they could have collisions in naming and port assignment, right? So I can tell you that within Marathon itself, it doesn't do anything to enforce naming conventions or port use or anything. Mesos doesn't, provided you use the ports abstraction correctly, Mesos doesn't let you bind to the same two ports at the same time, because a port is treated like a resource and only one task can have a resource at any given time. That said, that is a difficult organizational problem, and I would say different companies do it different ways. One way is to have like a mega master list of all the ports and all the services, and if anyone wants to add a new one, they have to go and refer to that list and make sure it's not already used, for example. Yes?
Mesos provide a feature to query what is being used.
Does Meso, sorry, go ahead.
Provides the capability to query what is being used, what services or ports.
So the question is, does Mesos provide a way to query what's in use? Yes. So it sort of does. What it does is it exposes endpoints that you can. They're just like RESTful endpoints that return JSON, and you can read and parse that JSON and see what's happening in the cluster. But it doesn't have like any kind of like magical search feature where you can say, is this port in use somewhere? It doesn't do anything like that, no. Okay, last question, and then I gotta hand it off. Yes, sir.
Can HAProxy Marathon Bridge be modified to use Mesos DNS name resolution?
It could if you're running it inside of Mesos, yes, presumably. The problem, right, is that typically you would run, I mean, it depends on what you're doing, but often you would run a load balancer on like a fixed host somewhere, right? Because a load balancer is a thing that you don't want to move ever. And you can't have a load balancer for your load balancer to get to your load balancer, because that could go on forever. If you're on AWS or something, it's relatively easy because you can use an ELB and then kind of forget about it. But I would say, yes, you can. If you wanted to change the etc resolve to point to your Mesos masters, there's nothing wrong with doing that. Yes? Okay. Thank you, everyone. I'm going to hand it off to this fine gentleman over here.